In this video, we're going to learn how to use T-charts to explain periodic trends. So first, we're going to compare the atomic radii of nitrogen and phosphorus. And we need to find some structural difference between nitrogen and phosphorus. So we'll first analyze their number of shells, or N. Nitrogen is in period 2, so it has 2 shells. Phosphorus is a period lower, so it has 3 shells. And there we have a difference that we can use. We can say that phosphorus has a larger atomic radius and is bigger because it has more shells. Next, we're going to compare the atomic radii of nitrogen and fluorine, and both nitrogen and fluorine are period 2 elements. But nitrogen has 7 protons and fluorine has 9 protons, and that is a very important structural difference between them that we can use. What we can say is that nitrogen is larger because although its valence electrons are in the same shell as fluorine's, nitrogen has fewer protons to pull in the valence electrons. Fluorine has more protons, and so its valence electrons will be more attracted to the nucleus and they're going to be pulled in. And so fluorine has a contracted radius relative to the larger radius of nitrogen, which just can't pull in its valence electrons with quite as much force. Next, we'll consider the atomic radius of nitrogen versus the ionic radius of the N3- anion. And right off the bat, we can tell the same number of shells, same number of protons, but what differs is the number of electrons, of which nitrogen has 7, but N3- has 10. So we can say that N3- is bigger because although, yes, the valence electrons are in the same shell in both cases, and they both have the same number of protons, what differs is the N3- ion has more electrons, and those more electrons are going to be pushing away from each other. They're going to be repelling each other and spreading out more, giving the N3- anion a larger radius. We are now going to consider the ionization energies, and we're going to make the same 3 comparisons, but just for ionization energy. And we can set things up the same way. We can compare the shell number. And what we can say is that nitrogen has a higher ionization energy than phosphorus because nitrogen's electrons are held closer. So if we've got, say, the nucleus of a nitrogen atom and the valence electron, maybe there's this distance between them and there's some attraction between them. And if I want to ionize this, I need to pull the electron away. Well, if we're talking about phosphorus, then the nucleus is going to be here and the valence electron is going to be here. There's a bigger distance between them because phosphorus has more shells, and it's going to be easier to pull away this valence electron. It doesn't require as much energy to remove it. Next, we'll consider the ionization energy comparison with nitrogen and fluorine. They both have the same number of shells, as we previously discussed, and fluorine has more protons. So we can say that because fluorine has more protons that will hold the electrons more tightly, fluorine has a higher ionization energy. In this case, it's almost like nitrogen and its valence electrons are separated by about this much distance, and fluorine's nucleus and valence electron will be separated by not very big of a different distance. Maybe fluorine's a little bit smaller, but what's really important here is I've got one nucleus that's positive 7, I've got another nucleus that's even more positive, it's positive 9. And so it's going to be pulling more on the valence electron, making it harder for me to rip away that valence electron. Finally, we'll compare N versus N3-, and again, the only difference is the number of electrons. Well, we can say that N3- has more shielding, and as a result, there's going to be less attraction between a valence electron and the nucleus because that valence electron will just have more other electrons interfering in between it and the nucleus. So because the N3- ion has more shielding and less attraction between nucleus and valence electron, it has a lower ionization energy N, there's greater attraction between the nucleus and valence electrons, and so it requires more energy to ionize. It has a higher ionization energy. Without going through something similar for electronegativity, I'm just going to say that you need to use the same logic as with ionization energy. But you need to frame any explanations in terms of an atom's ability to attract bonding electrons rather than the difficulty to pull away the valence electrons. So if we compare, say, nitrogen and fluorine for ionization energy, that explanation involved, there's a similar distance between the nucleus and the valence electrons. In the case of electronegativity, it's not about the nuclear attraction to the valence electrons, it's about the nuclear attraction to the bonding electrons between, say, a nitrogen atom and something else, or a fluorine atom and the same other thing. So what we can say is that for fluorine and nitrogen in terms of electronegativity, they both have a similar distance between the nucleus and the bonding electrons because their radii are kind of similar. They're pretty close. But fluorine has more protons in the nucleus, and those protons have a stronger pull. We're not talking about the pull on the valence electrons. We're talking about a pull on the bonding electrons. That's the only difference. So that's electronegativity. And then finally, we're going to talk about metallic character and reactivity. Well, metallic character and metallic reactivity, they depend on an atom's ability to lose electrons. That's what being a metal is all about, losing electrons. So a lower ionization energy means that something loses electrons easily, and that means that it has more metallic character and more reactivity as a metal. On the other hand, nonmetallic character and nonmetallic reactivity depends on an atom's ability to gain electrons. So if an atom has a higher electronegativity, it has more nonmetallic character and it has more nonmetallic reactivity. So if you're ever making some comparisons and you're asked about metallic character or reactivity or nonmetallic character or reactivity, you need to go to either ionization energy or electronegativity and use that as the core of your explanation. So I hope this video has helped. Feel free to leave any questions or comments in the comment section below. Thanks for watching.